Okay, I've got another quadratic equation here. Now, for this question, I would like you to do a few things. Could you please sketch the parabola related to this equation, show the axis of intercepts on the x and y axis, show the turning point, so the set of coordinates for that, state the domain and range for the graph, and I would also like you to state the axis of symmetry for that graph. So pause the video here and I'll come back in a few seconds. Okay, hopefully you were able to do most of these, if not all of these, but let's go through them together. Now, to start off with, when we're sketching this parabola, we're going to actually find a few things at the same time. To help us sketch the parabola, we're going to actually find the x-intercepts, the y-intercept, and the turning point. So we find the x-intercepts via factorizing this equation. We find the turning point by completing the square and putting it into the turning point form. From that, we can sketch the parabola. After it's sketched, we can state that domain and range, and we can also state the axis of symmetry, which we haven't really touched on yet, but we can state what it is by looking at the turning point location. So to start off with, let's factorize this and find the x-intercepts. Now, let's see if we can do this via one of our factorization techniques. So with either technique, we're still starting off with a by c. So we have 1 times by 24. Now we're taking the magnitude, so we don't care that that's minus. So 1 by 24 is 24. Now, what are the factors of 24 that add to -5? So you got 1 by 24, you have 2 by 12. You could also scale by 3, so you have 3 by 8. Okay, so 3 and 8, they add to -5, so -8 plus 3. So y is equal to x squared minus 8x plus 3x minus 24. Now, I'm going to use the decomposition method for this, but again, whether you use the decomposition method or the Australian method, we should get the same answer. Y is equal to, I'm looking at the first two terms, factorizing out what's common. So x, I'm left behind x minus 8. And then the second one, to get x minus 8, I'm going to factorize out 3. Now I've got the same set of brackets, which I should have, and factorizing out that same set of brackets from each term, left behind an x plus 3. So from this, when we're plotting it, we're looking where y is equal to 0. So along this, that's why we call it the x-intercepts. So where y is equal to 0, we're trying to find what those x values are. Now, the null factor law says that when this set of brackets is equal to 0, and when this set of brackets is equal to 0, this statement holds true. So we have x minus 8 is equal to 0, and we have x plus 3 is equal to 0. Rearranging these equations, so you're taking the 8 over to the other side, so x is equal to positive 8, and moving the 3 over to the other side, x is equal to -3. Let's put that in, -3, positive 8. Next up, let's look at finding the turning point for this quadratic. So I've rewritten this on a new page. Now, before we put this into turning point form, what's our mental model? Is it going to look like this, or is it going to look like this, the graph? Well, we have a positive a value, so expecting the graph to look like this. So if we have two x-intercepts, we will expect a negative y value for our turning point location. So putting this into the turning point form, we need to complete the square. For that, we're labeling our b value, our b on 2 value, and our b on 2 squared value. So b is -5. So again, we actually care about it being negative now. B on 2 is -5 on 2, and b on 2 squared is -5 on 2, all squared, which is positive 25 on 4. We then want to take our equation, we add and subtract b on 2 squared, where those first three terms are factorizing into a complete square. So it'll be x plus b on 2. Our b on 2 value is minus 5 on 2 in this case, minus 25 on 4. And when we combine these two, we're going to need a common denominator. So let's just scale this up to have that common denominator. So 24 times by 4, you should have 96 for that. So minus 96 on 4. Y is equal to x minus 5 on 2 squared. 25 plus 96 gives you 121. They're both negative, so we have negative 121 on 4. Now we're comparing this to our turning point equation. So for this to be a plus k, for this to be a plus, that negative is associated with the 121 on 4. For this to be a minus, h is actually going to be a positive value. So our turning point location is going to be positive 5 on 2, so 2.5, 5 on 2, or 2.5. And our k value is going to be negative 121 on 4. So going to be down here somewhere, not drawn to scale. Now, previously we found our x-intercepts as negative 3 and 8. Negative 3, 8. Connecting these. Drawing's a little bit off, but connecting these looks something like this, which matches the mental model of the shape of the curve. So everything looks good so far. We've found our x-intercepts. Now we want to find the y-intercept. To do that, we look at our original equation. We're letting x equal to 0. And so y of 0 is equal to negative 24. Again, it matches what it should be. As in it's a negative number, but not quite as negative as the turning point value. So we've got pretty much everything we need to know so far. Two things that we're missing are the domain and range and the axis of symmetry. Now, the axis of symmetry, because when we just plot out a regular quadratic function, let's say you're plotting out x squared. So if you have negative 2 squared, so x is equal to negative 2, it gives you positive 4. Or when x is equal to positive 2, it still gives you positive 4. So we see in this case, this x squared would be symmetric about the 0 point. In general, quadratic functions are symmetric about their turning point. And so our axis of symmetry has the x value equal to the turning point x value. So our turning point x value was positive 5 on 2, therefore our axis of symmetry we have x is equal to positive 5 on 2. And then for our domain and range, so the domain is the horizontal part of this graph that this quadratic function can be plotted across. And if we were to keep going for x values, it would keep shooting off in that direction, up and to the left. It would keep shooting off in this direction, up and to the right. So our domain is actually negative infinity all the way to positive infinity. Now, we're using parentheses instead of square brackets here because parentheses are when it's not actually hitting that value. So, for instance, if we had a number line, something like this, 1, 2, 3, 4, and you had something that looked like this, where it's plotted from 1 to 4, and it's actually touching the 4 value, but it's not quite touching the 1 value, it would look something like square brackets for when it's touching and parentheses for when it's not touching. So it would look like parentheses 1 up to 4 square brackets. Now you can't actually get to infinity, so that's why we have these parentheses here. Now, because negative infinity to positive infinity encompasses all real numbers, this is actually equal to all real numbers. So this would simplify to the all real numbers symbol. And then for your range, well, it keeps going up to infinity, but it actually goes down to this turning point value. It doesn't go below it. So our range for this question is negative 121 on 4. Now it actually touches that value, so it's got a square bracket on that side. And then it keeps going and it will keep going up to infinity. So comma, infinity with parentheses value. So with parentheses symbol. So that would be our domain and range for that question as well.